All right, this is lesson 611, Congruent Triangles. And yay, because flowcharts are back. Welcome back to you and welcome back to flowcharts. We're going to briefly review triangle similarity. We talked in earlier chapters that there are 3 different ways to prove that 2 triangles are similar. Angle-angle similarity means 2 angles in one triangle are exactly the same as 2 angles in another. That's why we call it angle-angle. And that makes those 2 triangles similar. SAS, or side angle side, meaning that 2 sets of sides have the same ratio. So 3 to 6 is times 2. 8 to 16 also times 2, same ratio, with the included angle, the angle in between, the one that joins them, with the same exact angle measurement. That is side angle side similarity. The third shortcut, or the third way we know how to prove 2 triangles similar, is side-side-side similarity, and that's when all 3 sides have the same ratio. So if I multiply these 3 numbers by 2, 5 times 2 I get 10, 8 times 2 I get 16, 9 times 2 I get 18. That shows me that those 2 triangles are similar. Now, it just so happens that the ratio or scale factor is 2 in both of those. It could be any number as long as it's the same for each corresponding side. Okay? When we talk about triangle congruence, 2 triangles that have two triangles that are similar have 3 sets of matching angles and 3 sets of proportional sides. Okay? That's for similar. Congruent looks like similar, but also has the equal sign underneath. 2 triangles are congruent, have 3 sets of matching angles and 3 sets of matching sides. So exactly the same size and shape. Okay? If 2 triangles are similar and their rocks are equal to 1, then the triangles are congruent. Remember, rocks means ratio of corresponding sides. When we do our flowcharts, we often, when we're comparing 2 side lengths for a similarity flowchart in triangles, we're saying, 10 over 5 is equal to 2, and our reason is rocks, or ratio of corresponding sides. When that ratio is actually equal to 1 instead of 2, that's when we know that the triangles are actually congruent. All right, so this is 6-1 in your book, and they're asking us to make a flowchart showing that these 2 triangles are similar. Okay, so I'm going to put it right here so you can see the triangles. Okay, and remember, in a flowchart, I want to figure out what information do I know. And in this case, I know all 3 side lengths. So I'm going to have 3 bubbles, 1, 2, 3, and they're all going to lead to a final bubble. The first bubble, I'm just going to pick 2 sides. I'm going to start with the smallest sides, 4.5, 4.5. So 4.5 over 4.5 is equal to 1. Anything divided by self equals 1. What's my reasoning? By this time, it's okay to write rocks, R-O-C-S. It means ratio of corresponding sides. Then I'm just going to pick the middle length. That's 6, and the middle length, that is also 6. So 6 over 6 is equal to 1. Now, in this case, you'll notice we're having the same numbers. Typically, I would say make sure you're using the same pattern. So left triangle over right triangle every single time. In this one, you can't really tell the difference, but in general, that's what we should be doing. Okay? Anytime we give a ratio of corresponding sides, our reason is rocks, ratio of corresponding sides. Finally, the longest side is 7.5. Longest side over here, 7.5. That's equal to 1. And you would just divide. You can divide on your calculator or simplify. In this case, obviously, it's easy enough. You don't need your calculator. But if it's not equal to 1, that's what you should do, calculator or simplify. Also rocks. So what information do we have here? We have side information, side, and side. So what we've just proven is that triangle, remember I can name this any way I want, ABC seems pretty logical, okay, is similar, if I'm using rocks, I'm proving similarity to triangle, well, let's see, okay, A is between the 6 and the 7, over here between 6 and 7 is F. B is between the 4.5 and 6. By the way, these, remember, aren't always drawn to scale. And if I want to, I can do the third one. Sometimes we just leave the third one blank. Okay, the angle that's joining 4.5 and 7.5, or the one that's remaining, okay? So what matches with A? Well, A is pink, F is pink. B, that's yellow, D is yellow. And C is blue, E is blue. Remember, the way that you order the first triangle doesn't matter, but the second one must match up to how you did the first. What's my reasoning for similar triangles? It is side, side, side similarity. There's our flow chart proving actually triangle similarity, okay? The next question, are these triangles also congruent? And the answer is yes. How do we know? Well, the ratio of corresponding sides is equal to 1, okay? So the triangles are similar, and both of these things have to be true, and the ratio of corresponding sides is equal to 1. Part C, what are the symbols for similar and congruent? I talked about it earlier. Similar is the tilde or the squiggle. Congruent is the tilde or squiggle with the equal sign, okay? Write a congruence statement for these triangles. So that's just going to look exactly like we did with our similarity statement, triangle ABC, only it says a congruent statement is congruent to, so I'm going to use the congruent symbol, triangle FDE. So you need to know those two symbols, you need to know the difference, and you need to use them in the right times. Okay, here's 6.2 part A, and again, reminder, triangles are not drawn to scale, so we just have to look at what's marked. Okay, are these triangles congruent, yes or no? So first we want to see if they are similar. Okay, if this is a right angle and this is a straight line, this also has to be a right angle. So they have one angle, they have another angle. So they're definitely similar by angle, angle similarity. And now we want to check to see if any side lengths are the same. And we're not given any numbers. However, this side length right here, D to B, is a given side length, and it's exactly the same in both triangles. Remember, we call that the reflexive property. So DB is congruent to DB. That's the reflexive property. We talked about that really briefly first semester. Okay? Because it's exactly the same, that means the ratio of corresponding sides is equal to 1. That means that they are congruent triangles. Okay? And because we're saying yes, we've got to make a congruent statement. If no, it's not no. So congruent statement, I'm going to say ABD, triangle ABD, is congruent to triangle. Now, A is not marked with anything. B has one tick mark. C is the right angle. Okay? So we're going from nothing to one tick mark to the right angle. So yellow, blue, black. So yellow, blue, black, CBD. Okay, that says if no, we're not going to, that one's a yes. All right, 6-2B, again, triangles are not drawn to scale. Okay, what's given information here? We've got two angles that are the same. Again, we've got this side length that's a shared side length. Okay, when that's a shared side length, I'm going to put an X showing it's congruent to itself. Again, that's called the reflexive property. CB is congruent to CB, and that is reflexive. Oops, not reflexive, or reflexive property. Okay, so we've got that those are the same. We've also got that these two sides are the same. So we have side angle side similarity plus, if these are marked exactly the same, it doesn't just mean that their ratios are the same, it means that they're the exact same length, okay? So the answer is yes, so because rocks is equal to 1 and they're similar, the answer is yes. So we can ignore the third bullet. Second bullet, triangle. I'm gonna go ABC again. No, I'm not. I'm going to go ACB so I can follow my colors. ACB is congruent. So I followed yellow, follow the yellow brick road. Okay, yellow and then pink. So I'm gonna go yellow and then pink, D, B, C. Okay, remember, it does not matter how you mark the first one, the second one must match up. Okay, letter C, again, triangles are not drawn to scale. These are the two kissing fish, or I forget what else your teachers have called it in the past. Two kissing fish means these angles in the middle are vertical angles. They have to be congruent, okay? I also see 6 and 6 are exactly the same, not just proportional, they are equal, okay? Then the other thing that I see is that these are parallel lines. And if we have parallel lines cut by a transversal, then alternate interior angles are congruent, okay? So I would say that these triangles are similar by angle-angle similarity. There's a pink and there's a yellow that are equal in both. That's similar by angle-angle similarity. However, even though this is a ratio of 1 to 1, this blue line is connecting the two angles, pink and yellow. This one is not in the same position, okay? So the two that I should be comparing, 6 and 4, that is not a ratio of 1, okay? So rocks is not a ratio of 1. So the answer is no, they are not congruent triangles. Yes, they are similar. No, they are not congruent, okay? So we're gonna write, or just circle, cannot be determined, okay? And in this case, the answer is just no. All right, part D, this is our last one. Again, triangles are not drawn to scale. Oh man, this is a mess. I am gonna redraw these triangles so that they're not overlapping. D with 2 arcs, A with nothing, B does have 1 arc and 1 mark. And then not overlapping, here's C with 2 marks, A with 1 arc and 1 mark, and then a B. So again, we've got angle, angle, those triangles are similar, okay? Similar by angle, angle, similarity. 2 angles in each marked the same. Now, this one's kind of tricky. They're overlapping, but the A and the B are exactly the same, right? The A and the B is the exact same length in the 2 triangles, okay? So these 2 are exactly the same length. That tells me, and it's the same, it's going from pink to nothing. So that tells me that the ratio of corresponding sides is equal to 1. So the answer is yes, these 2 triangles are congruent, okay? So if yes, I'm gonna say triangle ABD is congruent to triangle, okay, ABD, yellow to pink to blue, yellow to pink to blue, so BAC. Okay, that was pretty fast, but that's our first day with congruent triangles. We are proving that number 1, they are similar, and remember there's 3 ways we can show them similar. So we have to prove them similar first, then we have to find corresponding sides that have a ratio of 1, and that makes them congruent.